Okay, we'll continue, guys. Now, question 3A. They give you a function and they tell you it's 2xy plus y sine xy in direction I, and it's x squared x sine xy 6y in direction j. In this question, they're asking for two things. Is this conservative? Is the question conservative? And find possible function. To prove whether it's conservative or not, the one in direction I you call m, and the one in direction j you call n. You find the derivative for m with respect to y, and the derivative of n with respect to x, and you see if they're equal. 2xy, a constant y, derivative is a constant. Derivative this with respect to y, we have to do product rule. Derivative of y is 1 times the second one. Derivative of sine is cosine times the derivative inside with respect to y. The inside is a constant y, so constant times the second one. So we have to do the product rule for this one, but that's a derivative. We do the derivative for this one, for the second one that's in the j, with respect to x now. X squared is 2x. This one is, again, product rule. Derivative of x is 1 times the second function. Derivative of the second function is cosine times the derivative of the inside with respect to x, which is y, times the first function x, and the derivative of 6y with respect to x is 0. Are they equal? Yes. So my equals nx, therefore it is conservative. Now, how would you find a possible function for this? So once you prove it's conservative, you need to find a possible function. So what you need to do is you say f, x, y, and z, and integrate m. Don't put this, but this is just to remind you. I'm going to integrate m with respect to x. So the opposite of what we did. I'm going to integrate this with respect to x. The integral of this, a constant x, would be, we put the constant first, and then 2 over 2. Integral of this with respect to x, that's a constant, so it becomes minus cosine xy over whatever the constant down in front of the x was y, so you cancel this, 2 and 2, so the final is y x squared cosine xy. You say plus a function in terms of the other two variables, plus a constant, I'll call it C1. So first step, you say my function and integrate this with respect to x. So you integrate this with respect to x plus, say, plus a function in terms of the other two variables plus a constant. And then you integrate, you say, there's another possible function. We're going to integrate n dy. Again, don't write this. Just integrate this with respect to y. X squared is a constant, so integrating this would be s squared y. Integrating this with respect to x would be, respect to y would be negative x cosine xy over the constant in front of x, in front of y, which is x. And the integral of 6y would be 3y squared plus another function, I'm going to call it k, in terms of the other two variables. So this is y, so in terms of x and z, plus a constant c2. Now, once you integrate and you get the answer, let's simplify the answer a little bit. So simplifying the answer we got here, this is x squared y, cancel the x's, cosine xy plus y squared plus the k function plus c2. This is the answer for the second integral. So you say a possible function, you look at the two answers you got, this one and this one. You see the first term is common, the x squared times y, so you need that, but you only need it once. You'll see, so now we got rid of this. The cosine is also common, so we need this, minus cosine xy, but you only need one of them. 3y squared, we need it, because it's in this one. And this and this, the k function, the constant, the g function, the constant, you consider all of them a constant, and you say plus c. So basically you combine them. Anything repeated you show once, anything new must be part of the answer. So you combine the two answers. Anything repeated you show once, anything new you put, and everything else you combine them in a constant. This is the question from worksheet A. I'll do the same question that was in B. Question 3b, given the function y to the power 5 e to the x plus y plus 6x in direction I, 5xy to the power 4 e to the x plus y minus 6j. And the question, is it conservative? And find possible function. So to test for conservative, the first one is m, second one is n. You find the derivative of m with respect to y and the derivative of n with respect to x, and you see if they're the same. The derivative of this with respect to y would be 5y to the power 4. Derivative of this with respect to y would be itself times the derivative of the exponent, which is 1. and the derivative of this with respect to y is 0. We do this one. The derivative of this with respect to x, we have a constant in front of x, 5y to the power 4 in front of x, so the answer is 5y to the power 4. Derivative of this with respect to x would be itself times the derivative of the exponent 1, and the number has derivative 0. They're equal. Then yes, conservative. Once they're conservative, you can find a possible function. You integrate m dx. Don't show this. Integrating this would be a constant x. Integrating this is itself over the coefficient of x, which is 1. And the integral of this would be 3x2 plus a possible function yz plus a constant. You also integrate x, y, z. Now we're going to integrate the n dy. Integrating this with respect to y would be 5x, y, 5 over 5. Integrating this with respect to y would be itself over the y coefficient, which is 1. And the integration of negative 6 would be negative 6y plus a possible function k in terms of x and z plus a constant. Of course, the 5 and the 5 decancel out. So now we can find a possible function. I told you in the previous question, you look at the two answers, anything repeated, you include once. So xy5, it's repeated, so we need it once. Xy to the power 5. The e is repeated, we need it once. E to the x plus y. 3x squared is new, so it must be there, 3x squared. Negative 6y is new, so we need the negative 6y. The z and the constant, the k and the constant, you combine them all into a big constant, and this here would be your possible function. So this is question 3 from both worksheets. So there are 2 more questions left. I'll do them in the next part.